Welcome to a new test and teardown video. This time it's another Brüel Kjær. Phase delay unit 6202. As far as I can see, this thing is for audio use, also because of the milliseconds, but also they put in here the delay in meters, equivalent distance in air. So that is of course how you're going to move your the source of the audio with this delay, right? And you of course also got a variable delay, and you can click and then it's probably going to be off. Calibrate. Click, clack, and then there's an LED that will say when your delay is on. If we look at this unit is really small and lightweight. I don't expect to see a lot of good stuff in there, but when we look at the back, you don't see a power supply input anywhere. But what you see is two phase meter 2971. So I expect this is your power input. Probably also some signals in and out, I don't know. But it says here to 2971 input A. So that will be this unit's output. Ref input, that is probably the input to this unit, right? But you can also have an external clock input. So internal or external, we're gonna go for internal. I bet what we're doing is this is the clock. So all this is variable clock for a digital delay line or an analog delay line that is clocked. I expect to find some really cute IC in here for that. But so to power this unit up, what are we going to do then? I've been googling around and looking for a manual. This is obviously impossible as always with Brüel Kjær. So, but what we're gonna do is we're gonna find a phase meter 2971. And we just grab over here, and this is exactly what we're gonna find. A phase meter 2971. And what I wanna do is, I wanna power this meter up, and see, to external equipment. That is probably the connector, right? So I'm gonna measure the different voltages here, and this way figure out what kind of voltage to supply this one with. Isn't it the same kind of DIN with two extra pins? Yes, it is. Exactly what it is. Oh, I don't know if I got one of those connectors on stock. So we're gonna delay this a little bit. I need to go and find a connector. So here is the connector signals from the 79 or 2971. So this is the connector seen from outside. This is the top view, and there's this little thingy here on the top, as always with a DIN connector. So now you got all the different voltages. I don't know exactly about this 4 volt. Maybe this is a signal in out or something like that. And I don't know if some of them are like on-off signals or if they're just connected together. What I could do is I could power this unit off and then use an ohm measurement to verify if these three are always connected together. That's actually a good idea. That's a little bit annoying about the 3 plus 5 volts signals on the rear of this one. Now I power this unit off and use my ohm meter. None of them are connected together, so it's just pure random. They deliver 5 volts out completely isolated or whatever they do. A little bit confusing here. So, but anyway, if I connect this directly to my other unit here, my delay unit, I should probably be able to power it up, right? So I think this is the final result of the pinout. We got some D5, D4 and D6. I believe that's some sort of a data interface. and I verified the wire colors and the connections to the PCB in this unit here, the phase delay unit. All the wires from the connector, they go down to the PCB, and we got labels, so we aren't really completely stuck here. See, plus 15, minus 15, and so on and so on. So all this, we now know what is what. So I think I should be able to power this up, and this is really what I want to do now. We got the different the input here, and that goes down here. It's also written on that board. See, it says out, external clock. Got some really interesting ICs right here, 74, 36, 37s. And what exactly are they doing? I don't know yet. I am definitely going to look this up. Here is the switch for all the fixed delays, and that's the variable delay pot meter. They just like this click feeling when you turn this down to cal. They didn't even use that switch, as you can see here, completely unconnected. Other than that, I see just some gates and op amps, quite a lot of op amps from 75. So there's 76, this one is from what, 75. So this unit is probably from 76. Yes, that is the latest IC I can see. 1976. It's a 2-layer board. Oh yeah, and look at that. We got a crystal right there at 7.5 something megahertz, and this goes to some counters and dividers and all that kind of stuff here. I've been measuring around the last few hours. I mean, this is not an easy thing to get this one up and running. Obviously, I can't find anything at all, like manuals or schematics or anything like that. And everything is powered up. Power consumption looks good. Everything here is alive. Crystal is running. This is the oscillator and some dividers. Pulses go around in all those different parts. And when I play around with the pot meter here, the variable delay, then I can measure all places here about pulses getting longer or smaller, sine waves changing frequencies, and all those kind of things. So I mean, it really looks like it's alive, but the input and output is just inverted if the frequency is low. But the higher I go, then the phase changes. But it's not responding to any input at all here, and it's not responding to the internal external setting as well. So there's just no way for me to change the way that this thing kind of work. What we can do is just have a little look here. This is 18 kilohertz, and then the input and the output is in phase. But see, if I go a little bit up, a little bit down, see there is a phase change. And if I go all the way down, 8 kilohertz, 6, 5, 4, 3, 2, 1 kilohertz. Then it just looks inverted, right? And if I put in, I don't know, 100 hertz, see, it's just inverted. So, and the level is more or less constant all the way up there, but there is a phase change, but I'm just not able to manipulate the delay. Also, I'm not able to look up. Let me see if I can show you guys this. So the 7436 and 7437. I mean, they got to have something to do with the delay, right? Because it's connected to clock and it's connected to analog and input, and here is the external frequency thingy, and here is, I mean, how the heck is this variable delay working? I also see the filters, they are also connected to the input and output. Here we got some filter components, op amps, transistors and stuff. So, but how are they adjusted or selected, or variable delay? I don't know exactly what they're doing, but something fantastic smart is definitely happening on this board. But so far I think I will just pause my efforts for today and probably maybe release this and hope for some comments. Maybe somebody knows. Well, all this is just op amps, and that one is just a Smith trigger or some counter thing. Is not that important. This is just some normal gates and some counters and stuff. This is absolutely not important. I believe here is where all the fun is going on, right? Yeah. Switched thingy here. I don't know. Yeah, that was a big disappointment. I had a lot of fun anyway. It's probably working, but it's not working, right? It got all the right voltages and everything here is alive. There's just no way that we're gonna get any kind of variable delay out of this thing. So, bad day today. Here's the bottom side of the PCB layout, and here we got those 6 fancy special ICs, and here we got the switch for all the fixed delays. See if I can show you some really nice close-up pictures. Yeah, ICs seems to be from 1975. I mean, is it really that old? It looks quite modern, this PCB layout and everything. They got, oh yeah, this one is from 76. But anyway, thank you for watching, and I really hope you can help with a little bit of datasheet manual stuff like that. Could be cool.